scale-up of bioreactors. So whatever we are doing in the laboratory can be useful when scientifically we do these things for society. And one such thing is your bioreactors or fermenters where we can scale up certain products. Look into this flow chart, which is taken from a journal known as Trends in Biotechnology. The first step is the strain construction. What type of strains you require for your formation of your product. Then the fermentation process, quality control and development of the fermentation process. Then the downstream process, that is whatever the product is being formed, here you are removing or purifying that product. Again, once again, you have the quality control and the development, whereas this process are known as the upstream processing. Okay, then if it is a clinical product or any other product too, once it clears the quality assurance and quality control, it can go in for the manufacturing. During the manufacturing also, the quality assurance and quality assurance test should be cleared. So, where is the chance for our scientists to do any improvement? Here lies the chances in these steps. Improvement and scale up, you can do it here. That is why I told whatever we are doing in the laboratory, it can be useful only when scientifically we do these things for the society. I do something in the laboratory and then discard it after sometimes. No. It should come into the commercial market wherein it can be beneficial for the entire society. So, if it has to be beneficial for the entire society, what should you need to do? Whatever you're producing in the laboratory, will it be sufficient for such a million and billions of people? The answer is no. So that is why we go for what is known as the scale up. Scale up is the process, okay, of expanding or transition of a fermentation process from lab scale to industry level. That is from a smaller scale fermenter to a larger scale. That is known as the scale up. We shall explain the same thing using a model. Okay, before going into the details of the scaling up, let us just recall in the previous classes what we studied about. In previous classes, you dealt about the fermentation in the liquid media. It can be carried out either in the batch, fed batch, or continuous culture. Here, we cannot say any method is either superior or inferior. It depends on what type of product, what type of strain, what type of substrate, the physical and chemical parameters, what we are using. Which is more suitable? Is it the batch or fed or continuous method? Which is the best method? We can use that. So in stirred batch fermenter, we defined it as a closed system where all nutrients are present at the start of the fermentation within the fixed volume. In fed batch fermenter, the fresh medium is fed in throughout the fermentation and volume of the batch increases with time. That is, we are in increment manner, okay, we are adding the fresh media, but simultaneously we are not removing the spent material or effluent which is present in the fed batch. Therefore, what happens? Only I am adding, nothing is being removed. Therefore, the volume of the fed batch fermenter increases. Then we have the continuous culture. Here, the fresh media is fed into the vessel and spent media or your effluent and the cells are removed. So this is called as a fixed volume. Why? Because you're adding the fresh media At what rate you're adding the fresh media, at the same rate you're removing your spent material and the cells are being removed. Again, in the continuous culture, you studied about the chemostat and the turbidostat, and we also defined the steady state culture in the continuous culture system. So, whatever may be your fermenter, it depends on the pH, the temperature, aeration, the biochemical process, the baffles which you are using, the impellers, etc. And these all should be monitored and adjusted. And also, we have in the starting itself, we have defined what is a fermenter and what is a bioreactor. Actually, the word fermenter is particularly used when we are using microbial cells, whereas bioreactor is used when we are using animal or the plant cell lines. So, fermentation technology is a technology to grow cells in a large scale with high efficiency. It also includes product recovery process. So fermentation means it is a technology wherein we grow our cells, whether it is a microbial or animal or plant cell, in a large scale, which is highly efficient, and also it includes the product recovery process. That is, you cannot say when you are getting any product from a fermenter, you cannot say that it is 100% pure, right? What you do is, after the product is being produced, after it is being formed, you go for purification of that process or that product, and that is what is called as the downstream processing. So this is a point which you have to remember and which we had already spoken up. So here you can see various type of fermenters. So this is what I told you. What do you mean by scaling up? Scale up means you are producing something in a very large quantity. Okay, the scale up is a process of expanding, or it is a transition of a fermentation process from lab scale to the industry level. That is, in lab scale, what you're doing, you're using small scale fermenters. And in the industry scale, what you're doing, you're using a large fermenter. So the expanding of your process from your laboratory scale to the industrial scale, that is, from the producing a small quantity to a larger quantity, is known as the scale up. So scale up is perhaps one of the hardest and most complex steps of any fermentation processes. For engineers, it is really difficult because they need to study about the operational and production parameters before they do any fermentation for the production in the large scale. It is a compulsory, okay, it is a very optional for the operators to study about the operational and the production parameters. So, whenever we want to produce a product in very large quantities for commercial purpose, we directly do not use large scale fermenter, right? We cannot directly go and use the large scale fermenters. Generally, smaller scale fermenter is used where operational and production parameters have to be first studied and it should be optimized. Now, why? Why are you telling that we cannot directly use a large scale fermenter? Because here, the quantity what we are speaking here is not 100, 200 or 1 liter, 2 liters. No, it is can be 2 lakh to 5 lakh liters, tons of liters what we are producing here. And if I come directly and add all my substrate, whatever required for a fermentation here, and ultimately if I get a zero end product, what will happen? It is a total wastage. It is a total wastage of just not manpower. You have wasted all the chemicals. It is, in one word, we can say that it is an economical loss. What you have invested, remember that how much of money is being invested, and you end up in zero, back to pavilion. So no one will do directly anything in the fermenter unless until it is done in the lab scale. Whenever we want to produce a product in very large quantities for commercial purpose, we directly do not use large scale fermenter. Generally, small scale fermenter is used where operational and production parameters have to be first studied. So, an operator who is doing this has to first study all this. So, how can we transfer the information from lab scale to the commercial scale? Okay, I have studied all the requirements in the lab scale. Now I have to transfer it into the commercial scale. How are we going to do this? So remember penicillium, okay? You know that it is an antibiotics. So you know that penicillin is produced by the Penicillium chrysogenum, which is a species. It is used for production of penicillin, and it was successful in the lab scale in 2 to 10 liters. Now, if you want penicillin for a billion of people, is it possible for me to do just in 2 to 10 liters? No, highly unimaginable, right? Now, suppose you want to produce in large scale, then you need to go for an industrial scale. This might be what uh, 1 lakh liters, or it can be even like up to 2 lakh liters. It is very high. This method completely changed the process of drug discovery. Actually, the first penicillium was the first antibiotic which was actually produced in the large scale. So you can just imagine that how much revolution it brought about when Fleming did it in the laboratory, and today we are doing it in the laboratory scale. Of course, today we have different, we are just not producing penicillin, we are producing a different combination of penicillin. Anyway, we leave it at that point there. So this method completely changed the process of drug discovery. Its large scale production transformed the pharmaceutical industry. Whether lab or industry, we have to take into account whatever environmental condition prevailing in small reactor, similar condition should prevail even in the bigger reactor. So what condition I am following here, and if I get a positive results here, the same condition should be followed here, and here also I should get a positive result. So this is the main purpose of scaling up, and so that your organism should work in a similar manner and to give the same product. This is what is called as the scaling up. That is, I will do all my optimization studies, what is required, what is my strain, what are the physical and chemical parameters I want, what is the product I'm going to get, how can I recover that product. All should be done in the laboratory scale. And whatever the environmental, the strain, whatever you're using, you have to use the same thing even in your fermenter for the large scale, so that you get the maximum benefit what you got it in the laboratory scale. So the first level is using a shake flask. For why we are going for a shake flask? The purpose is for screening. That is, you're going to screen for selection of high yielding fast growing cell line, and the medium is optimized, which is usually carried either in 500 liters or 1 liter shake flask. Okay, so what is my first stage in the scaling up is I am going to scale up in the shake flask. Why are you going to use this shake flask? Is my purpose is for screening purpose, for selection of high yielding, fast growing cell lines, and the medium is optimized for growing these cells, and it is usually carried in the 500 or up to 1 liters it is being used. So here itself I've told the transfer of a process from a small scale laboratory equipment to large scale commercial equipment is known as the scaling up. Whatever I got it in small scale, whatever the beneficial efficacy I have got it, or the efficiency I've got it in the small scale, I should same thing I should get it in the large scale for commercialization. And now after we had done, we have screened and selected a high yielding fast growing cell. Next, what is the step? Then it is transisted to the lab scale fermenter, okay, or to the level of pilot scale. So either in the lab scale or in the pilot scale level, it ranges from something around 300 to 3000 liters, whereas your lab scale you can see it is 5 to 10 liters. So after I'm done with the shake flask, I can go for the lab scale or I can go for the pilot scale fermenters, which is about 300 to 3000 liters. The pilot scale level, okay, which is having a range about this 3000 liters or even 200 to 300 working volume, depending on the kind of production and product value, you are going to go for an industrial scale. So what is the use of your pilot scale? So my pilot scale is an acting as an intermediate between the lab scale and the commercial scale. So what is an intermediate means? See, whatever I got it in your shake flask or in the lab scale fermenter, I should reproduce the same thing in the commercial scale. So before directly going into this commercial scale, I use a pilot scale fermenter, which is of 3000 liters. I will use the same experimental parameter here in the pilot scale fermenter. Why I'm doing pilot scale fermenters? Particularly to see the reproducibility. Okay, so you would have done an experiment, and seeing your protocol, I would have done the same experiment. Since we are both are doing it in the same lab environmental condition, both the results should almost be same. Okay, that is called as reproducibility. But if you got some result and if I'm getting a lot of variation from your result, there is no reproducible. The results are not reproducible. The results cannot be judged. You cannot believe that result, and then you cannot bring it to the commercial fermenter. No, you should check where you have gone wrong, in which step you have gone wrong. So Hash said, in shake flask level, we are usually selecting a strain and we are optimizing the media. And here we check the technology and the economic feasibility of the process. So only few grams of raw materials are being processed here. Only few grams we take it and we study about it. Okay. See here, to develop the strain, to investigate certain aspect of the process, handling only small amount of raw material. It is at this scale a series of measurement concerning all mechanism independent of sizes made. Besides, measurement of physical parameters such as density, viscosities are made. That is, whatever the physical and biological parameters you want to set up, you do it in the laboratory scale. Then we come to the pilot scale. In pilot scale level is checked for the reproducibility, where optimization is done to bring it closer to the lab scale reactor level, and also environmental factors are optimized in the pilot scale. So here my purpose of the pilot scale is particularly I have to see the reproducibility. Whatever I got it in the lab scale fermenter, am I getting the same thing in the pilot plant? And again I should go for the optimization, so that whatever the result I'm going to get in the pilot scale should be closer to my lab scale, because in the lab scale I've got very good results. So I have to match it to my lab scale reactor level. And also the environmental factors here also it should be optimized. So here you what you're going to do to test the feasibility of the lab scale fermentation process in semi-industrial scale. It is almost semi-industrial in intermediate I do. Pilot fermenters normally have a size range of 100 liters to 10,000 liters depending on the product to be mass produced later. So your pilot plant is also known as an prototype. It is an experimental rig which at least in part has an operational characteristic representative of the main plant. So what is your pilot plant? It is also called as a prototype. It is actually representing your main plant. That is your commercial plant. It is representing it. So pilot plant allows simultaneous analysis of the effects of the physical and chemical mechanism on the process. Simultaneously, it will look into the what are the physical and chemical parameters in which they are interdependent upon or not. It allows the determination of the extent of possible interaction between the two types of mechanism. That is what we are going to do it in the pilot scale. So, in this scale, additionally, stability of the strain, impurities in raw material operation over long periods of time, material, equipment reliability are taken into account. It is during the pilot plant scale the problem of scale up is addressed. So, once we have done it with the pilot scale, next we go for the production scale. In production scale, we look into the economic value and perfect product formation or the substrate. If everything works fine for you in the pilot scale, then you can go for the commercial scale, that is the production scale. Also it is called as a production scale, because we are producing a product in a very large quantity, and here we are looking into the economic value and the perfect product formulation or the substrate, how well your substrate is converted into the product. We are looking that into in the pilot scale. Now if you look at the definition of scale up, scale up is the study of the problem associated transferring the data from the laboratory to the pilot equipment to the industrial production. We cannot use whatever condition that we have for a smaller reactor will not be applicable to the bigger fermenter. Okay, see here the whatever 100% result what I have got here, you cannot be or you cannot really get 100% in the large scale. Okay, but that doesn't mean that you can get 50% is okay, 40% no, at least 90%, 95% at least you have to get. Okay, the similarities should be so close enough. So we so we cannot use whatever conditions that we have for small reactor, it will not be applicable in the bigger fermenter. So the operation condition will be changed. So to maintain a similar type of environment, scale up is necessary. because here what is the operation condition, exactly the operation condition here will be very different. Okay, so we should avoid as much as possible this difference. Only if we avoid this difference, the scale up can be up to the mark. Okay, that is why scaling up is necessary. So as I said, the scale up of fermentation process is critical to the success of industrial fermentation for the production of biological material, because we should be able to treat tons of raw materials. Okay, the problem is to reproduce the laboratory result on the large scale to achieve the same productivity or same conversion of the substrate or product quality and selectivity. So this is little bit, that is why it is a very challenging. Fermentation technology itself is a very challenging business, because you have to invest lot of money into it, because you are going to invest, put into lot of raw materials, tons of raw materials, and you have to get tons of products, pure, highly pure variety you have to get. Okay, so that is why it is a very challenging, particularly when you're using going for the production of biological materials. Okay, we use very large amount, we cannot even use the word large, it is tons, tons, tons of raw materials. So the problem is to reproduce the laboratory results on the large scale to achieve the same productivity or same conversion of the substrate to the product formation, and the quality and the selectivity should be at the topmost priority. So, as a rule, one or more additional experiments are needed. That is, you cannot say that I will do only one experiment, then move to the pilot scale, and then move to commercial scale. No, you should, as a rule, it is a rule that more than one additional experiment is needed. Okay, only then you can see that how reproducible your results are. That becomes very important. So pilot scale plant, as I told, it is also called as a prototype. It is an experimental scale. These have an operational characteristics which are representative of the main production plant. It allows us to get a concurrent analysis of various physical and chemical mechanism on the process and their interaction between them. So the pilot plant allows simultaneous analysis of the effects of the physical and chemical mechanism, what I told you earlier itself, and what is the interaction between the physical and the chemical parameters. We study them here. And one more is we can check the stability of the strain. See, the strain is most important, right? If the strain itself is not working properly, whatever the substrate, whatever XYZ you're going to add, will it produce any product? No, it is not going to produce any product. So we have to check the stability of the strain for the presence, and we have to look into the contamination. Okay, the stability of the strain for the presence of contamination in the raw materials. That is, whatever raw materials you are adding, is that raw materials carrying any contamination? If it is going to carry contamination, obviously you know what product you will get. You will get the contamination in the product also. Not only that, you will get a very different type of product. Okay, and variation among the batch to batch method. Okay, so you're looking into the stability of the strain, You should see that your raw material doesn't have any impurities. And when you're doing batch fermentation, we told that everything one batch we complete and then we go to the next batch, right? So these should be kept in our mind. So one batch, if I have produced, the second batch also should provide me the same result. I cannot get a very different result in the second batch. So this also we should take care of. And the feasibility of sterile operation over long period of time. From the beginning, we are telling that sterility is the most important. If it is a very large scale equipment, you cannot carry the equipment and you cannot go and sterilize. So there will be an inbuilt sterilization. I told you about the coils, the jackets, hot water jackets, even the pipes which are connecting to your plant, that also should be sterilized, because we know that contamination is the biggest problem, whether it is in your animal cell culture or plant cell culture or microbial cell culture. And remember, these reactions are going to happen continuously for many days, and you're not going to disturb your system. I cannot stop my system and then again start sterilizing in continuous scale, and you cannot do that. So starting itself, you take all the precaution that you follow the sterile operation condition. So the reproducibility of the lab scale results at the production scale is very important. It is during the pilot scale that the problems of the scale up is addressed. So what are the problems you will be facing when I am going to do it in the production scale or commercial scale? That should all be addressed in your pilot scale. All the problems should be sorted out in your pilot scale. That is the meaning of this. So, regardless of how well you prepare, there will be issues that arise during the scale up. That is unavoidable. Scale up is crucial with respect to biological reason. For example, the inoculum quality. Okay, that is your strain and the media. It can differ at different scales because of the size of the reactor changes. In small bioreactors, the wall growth may not be that significant. Okay, where you can see one example here. Okay, so the inoculum quality, it can differ at different scales, whether it is lab scale, pilot scale, or commercial scale. It can differ because of the size of what? Of the reactor. It changes. In small scale reactor, the wall growth may not be that significant. These cells may have different physiology as compared to free cells. Okay, so whatever organism I'm using in the fermenters, that organism, when you compare to a free organism, their physiology and this free cell organism will be different when you compare. And here in small scales, you cannot see that the microorganisms are adhering to your glass vase or to your reactors. And you think that everything is going fine, but that is not the case. In the pilot scale or in the commercial scale, you might clearly observe, okay, that the cells might adhere to the walls, which may not be able to see it in the shake flask. So your inoculum quality can change and can be unreliable for the scaling up. Example, you can see here whenever we are using a filamentous fungus, neurospora. which grows on glucose, you can see that how much wall growth is adhering to the stainless steel parts of the reactors. Will there be any benefit or durability in such type of reaction? It cannot. And this is being hidden in your small scale reactors. You can't see that such things are happening. And only when you go to pilot scale and production scale, you'll come to know that okay, such type of problems are existing, particularly with the filamentous type of cells. So, what are the biological difficulties we face? Is the common example include the utility interruptions, microbial contamination, that is contamination from any other microorganisms. First of all, we are using microorganisms. There should not be contamination from any other organisms, either from your equipment or by your transferring, or if you are not doing the sterilization properly, it can all lead to microbial contamination. And if you yourself are not uh, maintained cleanliness or hygiene, that can also add to the loss. Variable raw material quality. So in one batch you would have got, see for example, I'm just telling, like if you want starch, you get a quantity, some quantity of potato. Again you want to prepare some material out of starch, so again get the potato. So is the potato infinite? No, it is finite. It is only of some quantity. Once it is finishes, again you have to purchase that so much of potato and use. So will it not lead to variability of the raw material? So can you really rely upon them? Not much. Okay. So fouling of the process equipment, because it is continuously running, what can happen? It results in the bad odor because of the unhealthy organism which is growing there. No proper hygienic condition is maintained. Equipment failure and unexpected poor process performance at the scale. So suddenly what happens? You don't know your equipment will be running, but suddenly it will fail. Maybe because of some power fluctuation or any internal problems in your equipment. Unexpected poor process, you'll everything is going fine, but you see the process performance at the scale is not up to the mark, and you don't know why it is happening. You have to do again a thorough study about it. So these are some of the problems what we face, the biological problems we face in the uh, fermenter when we are going for the production scale. Okay, we can stop here and we can continue in a next class.